Well, hi, good morning, and thanks so much for joining me here in my shop on a day that's starting out sunny and nice, but is going to turn into thunderstorms for the bulk of the day. So I think I'm going to get a lot done. The last radio I worked on, big cabinet, shortwave radio, I mentioned something about working on the cabinet. I'll probably do that today. But what I plan to do with this radio today is a preliminary or initial alignment, if you like. And if all I get through is just checking the IF, that'll be okay too, because sometimes complications occur when you do these things. So I'll just get as much done as I can get done in here today. So I think a good place to start is looking right at the instructions for how to align this radio. And then we'll go from there. Okay, so this is the schematic page, if you like, and in this corner we have the alignment instructions. And there's some interesting stuff in here. Often when you read the notes and things on these schematics, you can pick up little hints that in fact are general truths, if you like, among all radios that are only occasionally presented on these schematics, especially in these tables. And there's one in here, which we will get to. So alignment and sensitivity. So in this case, what they've done with this radio is they've given you a way to verify that the radio's sensitivity, or you can flip it around, its amplification of signals is as strong as it should be. And so what they're saying here, they're saying nominal sensitivity for 50 milliwatts output. So you would hook up your proper meter to the speaker on this radio and measure the milliwatt output if you have an appropriate setup to do that. In a professional shop situation, or certainly in a factory situation, this would be set up, so this test could be done very easily. Not quite so easy for me, but here they show you that this is the amount of input on the test equipment required to get to 50 milliwatts of output. As you're working your way, starting halfway through the radio and then backing your way up towards the antenna, it takes less and less signal to produce this 50 milliwatt output in the speaker. They see 2000 what? 2000 what? Gotta be, well, it must be microvolts. They just didn't put the microvolt thing in here. Microvolts per what? Microvolts per, okay, don't quite get this, what they're doing here. Don't know why they didn't put microvolts here. So I assume that's 2000 microvolts on the antenna, or oh no, not on the antenna, on the pin of this tube. Gives me a hint of how much I should expect my signal generator to pump in the radio to make it work at all when I do these. So that's interesting. Very few radios contain this information. Just for output. And minimum set. Instructions on how to set the tuning gang. It's not important on the first step. First two steps are the IF. This is what I hope to get through. The IF alignment, 455, no surprise. Go on the IF amplifier tube, pin 1. Now this is the part that I think is interesting. The last radio I complained at this point that it said it had a chart like this and a column like this. It said dummy, but it didn't really explain dummy where or what. This one says through series dummy. Maybe they shouldn't even use the word dummy, because look, if you're going to run the signal through a 0.05 capacitor in series, this dummy thing has to be hooked up to this pin. But I would think dummy always refers to the antenna, a dummy antenna. So that's why I think this is confusing to me, because I'm trying always to relate it to the antenna terminals. But at least the engineer who did this made this clear enough for me to make this very deliberate error, and no, it won't be an error. Run the generator signal through a 0.05 capacitor. Okay, enough complaining about what people say on schematics. We're ready to go. Okay, straightforward. So I already have my signal generator operating, so it's warmed up, but the radio's not on yet. What we have to figure out was that pin. Let me just put the instructions up on my own screen here. Pin number 1. So which tube? This has got to be the tube in question. It's right between the two IF cans. So this will be the IF amplifier here. Does that make sense? RF amplifier, mixer tube, IF amplifier, detector tube, and audio output tube, and the last guy way over here, rectifier tube. Okay, that'll make sense. Nice straight line. Boy, that's great. So this tube, we'll flip up the radio here. That's this tube. Pin number 1 is easy to find. It's right there, coming out of this IF. Earlier on, I had mentioned that the IF, one terminal of the 4 IF terminals on each of these 2 transformers have been painted with green paint. And I wondered, what terminal is that? Well, it turns out it's the same terminal that's feeding the grid here. So it's the secondary side of the IF. Probably an observation that's not going to help me at all, but I made it. I mean, that's part of what you're trying to do here when you're working on these things, and pretty much anything in life, is make as many valid observations as you can. 0.05 capacitor. Grab one here. Here's one. Okay. And I'll clip it on to the correct spot. Oops. Okay, it's not going to wiggle or short. That's good. That's really good. Now, I got a negative lead and a positive lead, or a grounded and a hot, or however. Don't use any of those words. This can go to the chassis or it can go to the B minus. If it goes to the chassis, then it's isolated away from the B minus circuit by this capacitor, which I still haven't done anything about. No, we want this right on the B minus. As scary as it might be, to connect it right into the radio. Now, just for me in my shop, and for those of you who haven't watched many of my videos, I'm powering this thing with an isolation transformer. This is fed not from the wall, but from an isolation transformer. This ground terminal goes nowhere. Look, there it is there. It doesn't go anywhere. So, remove this. So as this radio sits here, if I power it up, I can stick my foot on my concrete floor here and stick my tongue on the chassis. No, can't do that. What I could do, I could stick my bare foot on the floor, grab a voltmeter lead here, grab the other voltmeter lead and touch the chassis. Find out what the truth is. Would probably read around 60 volts, half of 120. So if that makes sense to you, what I just said, then good for you. If it doesn't make sense, then you need to do a little bit of reading up on hot chassis and stuff like that. So I'm not going to go into it in detail. It's a topic in itself. There's great videos. There's stuff on the internet you can read. Hot chassis is an issue with this radio for sure. The thing is, this is what I'm trying to get to. So this is a power company ground. I mean, it goes right back to my signal generator over yonder. This is basically attached to the 3rd prong on that piece of equipment, right into the power company ground. And I hate to use the word ground because it's just a little bit vague. As soon as I have put this on here, I have defeated the isolation of the radio. That's gone. And the radio is now grounded. It's grounded here at this point. That means that other voltages in here now that can be referenced to ground or can drive current into the ground or the earth or into any of these pieces of equipment or anything like that. Should I be, putting my hand on a piece of equipment? This not being a good choice because I think this is a 2-pronger, but let's pretend this is a 3-pronger. I got my hand on it. Danger, Jim. Big danger touching anything now. Take this away. Danger gone. Put it back on. Danger back. So when I say I'm operating this from a isolation transformer, the thing that is keeping me safe here, the thing I have to count on, and so do you, is my brain, my knowledge, my experience. I've gotten enough shocks to straighten me out in here on what works and what doesn't. So to say, oh, just throw in an isolation transformer and you'll be safe. No, you can't say anything like that. So I'm sorry to dwell on this, but sometimes I have new viewers. They are watching what I'm doing. I'm thinking they're in their homes with their own 5-tube radio and a voltmeter, and that's about it. And they're poking around, and yikes, they're in sock feet standing on the garage floor. Yikes. I worry about that. So remember, your safety is your problem. So I'm gonna I'll clip this on here when the time comes. Having talked way too much about stuff I don't like to talk about. I don't like to talk about that stuff because I know I'm not doing a thorough job on it. So okay, let's get back to the actual radio. Maybe I should turn it on at this point. Sure. Power on. Okay, through the dim bulb just to be sure all the time. Everything's fine. So we'll give it the full treatment. Today the full treatment is 122 volts. Here we come. Goes quiet when I touch this. So I have to guess I am just simply reducing the impedance of the circuit to the point where the signal that's there just is so weak you can't hear it out of the speaker anymore. Same thing will happen when I hook this up. Great. Let's turn up the volume. Hey, it's still there. There's that thing I mentioned about you can always correct a problem in a radio just by turning the volume up. Same thing in a car, by the way. So my car needs brake pads changed. I got them on order. But right now my car is going as I drive down the road. Drives my wife nuts. So I fix it by turning up the radio. Same thing. Great. Now, let's get this guy onto 455. Change the lighting here a little bit. Make that a little more visible for you. 455. We have a weak signal. I heard absolutely nothing. Oh, what was that? What did I just hear? Is that my imagination? No. So, you know, if you're doing this kind of work and at the same time you're hearing things, it's probably not good to continue. Let's give it a little more. 10 times. There it is. You can hear it now. And give it a little more. 10 times more. No question. What's that swooshy thing? So that's probably another signal running through the IF, probably coming from the antenna, a noise signal in my shop, or maybe even a radio signal, and it's in there together with the this signal too, and the two of them are heterodyning or something like that's going on. So what I'll do is I'll get the noise back. If I tune the radio, it'll probably change. Yeah, sure enough. So I'm just going to tune the radio to where there isn't any of that. It's pretty quiet there. Good. Now I'm missing something. I am missing the, I didn't get the, either an AVC meter going in here or a audio meter or both. Yeah, maybe that. Okay, let me stop for a sec here. I'm going to set up a little more equipment. Why stop? Why stop? You can do it. You can do it fairly quickly. Don't bother stopping. I assume the reason you're watching my video is to watch me do this stuff. Okay. So this meter, my son bought me this meter at a yard sale in Ottawa for a couple of bucks. Can you believe it? I got it home, I changed 1 or 2 tubes in it, and this is a beautiful, beautiful lab quality meter. Lucky me. So we want to put this onto the audio of the radio. Now, I gotta hesitate for a minute. So I have this ground connection here, so there is a grounding of the B- in this radio now. This is a, I think this is a 3-prong meter. this is actually tied back to the power company ground. So is this. So this is a little dangerous to put anywhere but on the B- in the radio. Now, quite often in these radios, the speaker voice coil is completely isolated from the radio via the output transformer. But in other radios, it's not, and there's a ground, sometimes a wire from the chassis up to one of the voice coil terminals. And I want to know if that's the case here before I make a mistake. So when I look up here, ooh, did I touch something there? I don't think I touched anything. What's this tube again? Still got tube contact issues there, I think. So one wire is uninsulated and the other one's insulated. That's a hint that the uninsulated one is tied to the chassis. And why wouldn't they insulate both? They pay the money for the insulation. They can save that. So we got to look at the schematic to sort this out. And let me just take a glance here quickly, and then if I see something interesting, I'll throw it on the screen. Glancing. Okay, let's put this on the screen for sure. Okay, so we look at the speaker here, and sure enough, I have to look a little closely here at what's going on. So here is a connection to the chassis associated with the secondary and the voice coil. This has to be the voice coil here of the speaker. So there is a chassis ground. Okay. So what happens if I put the ground, hello radio, if I put the ground from my instrument over here, well, that would short this right out. So if I hook the ground up on the wrong side, the speaker will stop making the sound we're listening to. And so I can do that for briefly. It's not going to hurt anything briefly. Then we'll figure it out from there. So think about it. Now you could turn the radio off, hook your wires up, put a ground across the speaker, turn on the radio, can't hear any sound, turn up the volume, and start doing troubleshooting. Why am I hearing no sound? Meanwhile, you got a short across here. I don't know. I don't know if that's really a serious concern or not, but I'm going to be careful about it. Okay, back to the radio. So I have my ground. Let's see. So one is bare. That should be the ground. I should be able to hook up there and nothing much happened. Scary, man. Nothing happened. Now, am I full of crap? Hook up the other side. I'm full of crap. Look at that. Didn't make any difference. Well, so I'm being careful about something I don't need to be careful about. What harm is that? Okay, I don't want to bugger up the actual. And how about the meter's on? Did I turn it on? I must have turned it on. Here we are. Jumping around. How come you're jumping around? We can't have this jumping around, of course. We're relying on it here. I got a bad wire. Let's be sure of this. What's going on? Didn't I say something about I was going to do this off camera, and then let's try a different clip lead here. Now, is this because the other clip lead, the ground wasn't really there? No. Okay, that's better. some leads to fix up. Oh, you can't even see the pointer. Crying out loud. For crying out loud. Those are all the things I usually take care of on a off camera. Okay, so we have this guy going. Do we really? Let's turn the volume up and see if it goes up and down. Oh yeah. Good. That's ready. ABC, let's not worry about it now. We don't need it. We got this. So we're ready to do this transformer, the second one, not the first. Second one. Get a little tool here. How bad is it? Okay, watching the meter now. I got it even a little bit better here. There, that's better. See the pointer? There we go. 455. I need this to be right on 455, which in my world is actually 454. Now we're ready. There. Okay, watching the meter. Way off. It was way off. Okay, now the bottom. Let's go this way. Bottom of the correct one. So when they're quite a ways out, sometimes you got to go back and forth a few times. Now here we go. Up and down. Now, so what this proves? See, it really was adjusted correctly. Is somebody twiddled those slugs that are protruding at the top of the radio, just to see. I mean, you can understand somebody doing that. Let's just check the top one again. I used to do that when I was a kid. That's how I learned all this stuff. Messing everything up. I was okay with TVs, but I was terrible with radios. Funny, eh? You'd think, wait a minute, how can that be? Are TVs more complicated? Well, sure they are. So for the most part, a TV repair amounted to figuring out which tube to change. Not so much with a radio. Okay, it's right there. Good. Now, next thing. We don't have to listen to that all the time. Let's look at the next step. Go to the 12BE6. That's the mixer tube. Pin number 7. Use the 0.05 again. This time set the gang at minimum capacity. I'm going to do that right now because I'll forget that. Minimum capacity would be open. And you could hear the string pop there. What? First and second IF. Usually you don't go back, but maybe what they're suggesting here is it's better to have the two IF transformers, let's say tuned to 452, than to have one at 455 and one at 452 by accident. So maybe what they're thinking is, when you do the second one, you go back and make sure. Let me correct that. After you've done the second IF, and then you do the first IF, you should go back and make the second IF match the first, based on whatever frequency you've got going here. You know, back in the day, knowing your signal generator was at 455 was not easy. I mean, today I've got little digital numbers to look at, but before that, you're looking at dials and stuff. So that's probably the idea here. What they're really saying is at least make sure they're lined up on the same frequency, close to 455. Okay, so pin 7 of the 12BE6. Away we go. Pin 7 of the 12BE6. Okay, so the radio's operating. I think I can get this out of here safely. Let's take this off. This is clipped in here pretty good. Oh boy. Okay, I got it. And now we want to go on to pin 7 of the 12BE6. So go up a tube. So that's the mixer tube. And pin 7. Pin 7, so there's the gap. Pin 7. Pin 7 is that pin with the wire coming off it and going up to this coil, this weird floating wire connection. Pin 7. Well, that's pin 7. Now without, I'm going to turn the set off because my fingers are getting in here too tight. Without shorting anything. Oh, the wire is so slight. Yikes. This big mean clip lead here. Chew that wire to pieces in a second. Okay, we're good. Power back on. So now the signal input should go down a bit from where it was. Now where was it? We can actually figure out roughly what was going over there. I didn't calibrate this. Let's calibrate it. So to calibrate it, we have to do this, and then we've got to do this until you see that pointer stop at 10. So it's 10 microvolts times 1,000. So that's 10,000 microvolts. 10,000 microvolts. I was putting in more than that because I turned it back. 10,000 microvolts. Let's just use that off. Put this back like this. Put this back like that. 10,000 microvolts. And what did it say on the chart? I'm just going to take a peek myself. What did the chart say? It didn't say any 10,000. 2,000. Well, that would be 2,000 if everything is aligned properly. Well, of course, you're in the start. When you start, that's not the case. So anyway, I'm in the ballpark. It's a very, very large ballpark, but I'm in there. So we're going to put this on. I've knocked that down by a factor of 10. We should hear it. Try it up a bit. Now that noise, again, could be reception. Yeah, so we're going to move this off. Who knows what's there? To a quiet spot. Right there. Okay. Is that really the voltage here? Yes, it is. Right down the next IF. So, being careful now not to flub it. The next IF is up here. Start on the bottom. This is the one that most likely was not fiddled with. Then we should start on the top, shouldn't we? If I think one was fiddled with, let's unfiddle it first. Isn't this the way I went before? Maybe not. Okay, we're there. This one. Come on. This is the hardest part here. Oh, you son of a gun. Patience wore out. got it. I got it. Okay, good. Ready now on the meter. Oh. So once again, somebody's probably twiddled the top. Innocently trying to help out. Let's turn this down a little bit here. Innocently trying to help the radio out. And now don't make a mistake. It's this upper one. Got it. Watching. Oh, this one's off too. Maybe my theory's all wrong, so put that at max. Do the top again. Make sure you're doing the right one. Come on. There we go. Here we go. That's it. Right there. Okay, we'll do the second one now just to be sure. I don't think I've changed my signal generator at all anyway. Here we go. Watching now. There was absolutely nothing wrong with that. And we'll check the bottom here. Of the first. Bottom of the first. Sounds like a sports game. Here we go. Whoops. No. It's not the easiest tool to get in there. There we go. Ready now? It went up. Oh. What happened here? Maybe I got the tool on the wrong transformer there at some point. Okay. Let's keep going. Or maybe this is why they said do it. Do this. Even a touch more there. Let's go back to the first. Now you can kind of overdo this a little bit by getting the bandwidth so tight that you'll lose fidelity in the radio. There. And watching. Yeah, it was good. We're good. Good on the IF. Okay. Now I was going to yank that out. Yank that capacitor out of there. And rip that wire off right then and there. I don't want that to happen. I'm trying to avoid those kinds of dumb mistakes. Let's get it out of here carefully. You know, the clip leads. The clip's got teeth on it. Okay. What do we got for a radio now? Now that should have improved its operation to some degree. Let's give it a go. I think I can leave that hooked up for now. Back on. How did we do? Okay, based on just the loop antenna there by itself, we're way up at the high end. There's nothing up here to get. I'll go down to the grade in this range here. We're looking for a French station. Well, I didn't hear it, but I may have missed it. Now, we got some stations down here last time, weekly. wants to come in. Oh. One station only. Oh. I hear a voice there. It's French. So, now you can hear it fairly well like that. Well, maybe not fairly well. So I think this radio has the potential to receive this French station loud and clear. That's definitely not loud and clear. That's quiet and fuzzy. So hopefully the next alignment steps will enable that. If not, then the deal is there must be more defective components, because this radio should work really well. And it's always possible the tubes themselves are weak. I haven't tested any of them yet. I'm letting the radio do the testing for me. So, you know, there's a series of things that you need to go through. You can do them in any order you like. It doesn't really matter. Just, you know, pick your preference. I'm sure a lot of people want to test the tubes right off the bat when they get a radio like this. First thing, nothing else done. Tube out, test it. I like to do things differently. Okay, so I think I'm going to leave it there today. I'm not going to go any further with it. And tomorrow we'll finish off the alignment and make some judgments about components and the condition of the radio and all that kind of stuff. And voila. Meanwhile, I got a big old cabinet to start scraping. Fantastic. So thanks a lot for watching, and I hope you enjoy your day. See ya.